So this is the given problem. Signal x of t is equal to 10 cos of 1000 t plus pi by 3 plus 20 cos of 2000 t plus pi by 6. It is to be uniformly sampled, and we have to find what is the maximum allowable time interval between the sample values which will ensure faithful signal reproduction. And second one is, if 1 hour of signal to be reproduced, then how many samples need to be stored. So first we have to calculate the f max by using Nyquist rate. So we write here the given expression. So we compare this equation with the standard equation. Standard is 2 pi ft f1t and 2 pi f2t. So we compare this 2 pi f1t with this equation, and we get f1 is equal to 1000 divided by 2 pi, and here f2 is 2000 divided by 2 pi. Therefore f1 is equal to 159.15 Hertz and f2 is equal to 318.3 Hertz. So here maximum frequency is f2, 318 Hertz. So Nyquist rate Fs max is 2 into f2, that is 2 into 318.3, that is 636.6 Hertz. Now we have to find the maximum allowable interval. Next, this one is the first part, this is second part, that is maximum allowable interval between samples. So this is nothing but the sampling interval. This is sampling interval. So Ts max is equal to 1 by Fs max, that is 1 by Fs max is 636.6 Hertz, that is 1.57 millisecond. Now the next part is how many samples need to be stored. So we have to find the number of samples per hour. So number of samples per second is this one. That is 636.6. So number of samples per hour is 636.6 into 3600, that is this much second. So it is 2.2918 into 10 raised to 6. Next is determine the homogeneous solution of the system described by yn is equal to yn minus 3yn minus 1 minus 4yn minus 2, that is equal to x of n. So here the step 1 is assume input is x of n, it is equal to 0. So the above equation is y of n minus 3y of n minus 1 minus 4y of n minus 2 is equal to 0. Now the next is step 2. So here we assume the homogeneous solution. Assume homogeneous solution is in the form y h of n is equal to y of n. So thus y of n minus 1 is, this is lambda raised to n, so n minus 1 is lambda raised to n minus 1, and y of n minus 2 is lambda raised to n minus 2. So this is equation 1. This one is equation number 2. So next is step 3. So we put these values in equation 1. In equation 1. So the equation will be lambda raised to n minus 3 lambda raised to n minus 1 minus 4 lambda raised to n minus 2 equal to 0. This is equation 3. Now from this equation we take lambda raised to n minus 2 outside, taking common. So we get equation lambda raised to n minus 2 in bracket, this is lambda n into lambda raised to minus n plus 2. So multiplication of these two will be 1 minus 3 lambda raised to n minus 1 dot lambda raised to minus n plus 2. So multiplication of both these will be 1, and it is minus 4 equal to 0. So lambda raised to n minus 2, it is, so we solved it. Lambda, when there is a multiplication there is a addition of the numerator, so it will be lambda square minus 3 lambda minus 4 equal to 0. So this is our equation number 4. Now we have to obtain the roots of this equation 4. Now obtain roots of equation 4. So for that formula is roots is equal to lambda is equal to minus b plus minus square root of b square minus 4ac divided by 2a. So here a is what? Here a is 1, b is minus 3, and c is minus 4. Therefore lambda is equal to minus of minus b is plus 3 plus minus square root of b square minus 3 square is 9 minus 4ac divided by 2a is 1. So it will be 3 plus minus square root of 4 into 4 is 16 minus plus 16 plus 9 is 25 divided by 2a. So it is 3 plus minus 5 divided by 2. So there are two roots. Lambda 1 is equal to 3 plus 5 divided by 2, and lambda 2 is equal to 3 minus 5 divided by 2. So it will be, or you can write this one as a minus and this one as a plus, whatever you want. Okay, so it will be 3 minus 5 is minus 2 divided by 2 is minus 1, and it is 8 divided by 2 is 4. Now the next is step 4. Now the homogeneous solution. The homogeneous solution is given by, this is a standard equation, so y h of n is equal to c1 lambda 1 raised to n plus c2 lambda 2 raised to n. So h of n is equal to c1, value of lambda 1 is minus 1 raised to n plus c2, value of lambda 2 is 4 raised to n. This is our equation for you. Now we have to obtain the values of c1 and c2. Now obtain values of c1 and c2. So next is step for you. Now from equation for you we get what we get from equation for you. We get for n is equal to 0 and for n is equal to 1. Now for n is equal to 0, y of 0 is, n is equal to 0, y of 0 is c1 plus c2, and for y n is equal to 1, y of 1 is minus c1 plus 4 c2. These are the equations 6 and 7. Now step 6. Now we take the original equation. Now take original equation. Now what is original equation? Original equation is y of n minus 3y, which is given in the problem, minus 4y n minus 2 equal to 0. Therefore, what is y of n is equal to, all these terms go this side, that is 3y n minus 1 plus 4y n minus 2. This is equation 8. Now here also we have to find for n is equal to 0 and n is equal to 1. So the y of 0, n is equal to 0, 0 minus 1 is minus 1, so it is minus 3y into minus 1 plus 4y into minus 2. This is equation 9, and y of 1 is what? It is 3y into 0, means it is 0, plus 4y into minus 1. This is equation 10. Now we put this equation 9 and 10 in 10. Now put equation 9 in equation 10. So we get y of 1 is equal to 3y, not 3y, 3 into y of 0 is 3y minus 1 plus 4y minus 2 plus 4y of minus 1. So we solved it, and it will be, it is 9y into minus 1 plus 12y into minus 2 plus 4y into minus 1. So it will be 9 plus 4 is 13y into minus 1 plus 12y into minus 2. This is equation 11. Now next is step 7. Now equate the equations in step 5 and 6, that is equate y of 1 from the steps 5 and y of 1 in step 6. in step 5 and step 6, that is equating which equations? Equating 6 and 9. Equation 6 is what? Y of 0 is equal to C1 plus C2, and equation 9 is Y of 0. So C1 plus C2 is equal to 3y of minus 1 plus 4y of minus 2. Similarly, equate equations 7 and 11. So equation 7 is minus C1 plus 4C2, that is y of 1, and equation 11 is y of 1. So it is equal to 13y of minus 1 plus 12y of minus 1. Sorry, minus 2. So this is this one is the equation 12 and this is equation 13. Next is, here we have to solve the equations 12 and equations 13. So solve equations 12 and equation 13 to obtain C1 and C2. How to solve? We add equations 12 and 13. So it will be C1 get cancelled. So it is 5C2 is equal to equal to 16y into minus 1 plus 16y into minus 2. So C2 is equal to 5 comes here, 16 by 5 y of minus 1 plus 16 by 5 y of minus 2. This is the value of C2. Now we will find the value of C1. So this is equation 14. Now put this C2 value in equation 12. So we get the values. Equation 12 is C1 plus 16 by 5 y of minus 1 plus 16 by 5 y of minus 2 is equal to 3y of minus 1 plus 4y of minus 2. So we solve this. So C1 is equal to 3y of minus 1 plus 4y of minus 2 and these terms comes this side. So it is minus 16 by 5 y of minus 1 minus 16 by 5 y of minus 2. Now we solve it. Now we solve these two terms, that is 3y of minus 1 and minus 16 by 5y of minus 1. So 5 into 3 is 15 minus 16, that is minus 1 by 5y of minus 1 plus 5 into 4, 20 minus 16, that is 4 by 5y of minus 2. This is the value of C1. Now step 8. Step 8 is, now this is equation number 15. We put these C1, C2 values in equation 5. equation 5 is previous equation. So y h of n is equal to c1 is what? Minus 1 by 5 y of minus 1 plus 4 by 5 y of minus 2 into minus 1 raised to n plus c2 is what? 16 by 5 y of minus 1 plus 16 by 5 y of minus 2 into 4 raised to n. So here if we assume the initial condition 0, so y of minus 1 and y of minus 2 will be 0. This is equation 16. Now if we assume initial conditions 0, that is y of minus 1 is equal to y of minus 2 is equal to 0, then equation 16 will be y h of n is equal to y of minus 1 is 0, this is 0, this is 0, so it will be